Hello everyone, welcome to Botany channel for UPSC examination. In today's video, we are going to see the topic called Respiratory Quotient. This topic belongs to plant physiology and it has been given in your UPSC mains examination for Botany optional. Before starting the video, I request you to join the Telegram channel of the same name, that is Botany optional for UPSC examination, on the Telegram platform. And I would like to tell you that the Hindi version of this video will also be created and uploaded simultaneously. Alright, so those who are preparing the UPSC examination in the Hindi language can watch those video as well. Alright, so let's start the topic called respiratory quotient. So first of all, what is respiratory quotient? Now it is a ratio of volume of CO2 evolved to the volume of O2 consumed during the respiration. That is, during the process of respiration, the volume of CO2 evolved to the volume of oxygen consumed. That ratio is called as the respiratory quotient. As you know, during respiration, we take oxygen and release the carbon dioxide, that is CO2. So the ratio between the CO2 evolved to the oxygen consumed, it is called respiratory quotient. Well, it differs on the basis of respiratory substrate. That is, what is the respiratory substrate which is used during the respiration will affect the respiratory quotient. That is, respiratory quotient is different for the different respiratory substrates like carbohydrates, fats, or say in the anaerobic respiration. So let's first talk about the carbohydrates. If we take the carbohydrates as a respiratory substrate during the respiration, then we will have equation like this: C6 H12O6 plus 6O2, which will give 6CO2 plus 6H2O plus energy. Alright, so we are using here the carbohydrate as the respiratory substrate. And now from this equation we can see that we have used the 6 molecule of oxygen and we have evolved the 6 molecule of carbon dioxide. So respiratory quotient is nothing but the ratio of CO2 evolved and O2 consumed. So in this case, the 6 CO2s are evolved and we have used the 6 oxygen molecule. So the respiratory quotient will be 1 because 6 ones are 6. So we have respiratory quotient as a 1. So for carbohydrate, the respiratory quotient is always the 1. Now when we consider the another type of respiratory substrate, for example fat, we will get the different result. Now for fats, we are using the fatty acid called tripalmitin. Now this tripalmitin is written as 2 molecules of C51H98O6, and for this we require 145 of oxygen molecule, which will give 102 molecules of CO2 plus 98 molecules of H2O plus energy. Alright, so when we take the fat as a respiratory substrate, we have taken the example of tripalmitin. Here we have tripalmitin and we have used 145 of oxygen molecule and we have evolved 102 of carbon dioxide molecule. So in this case, the respiratory quotient will be 102 CO2 molecule divided by 145 of O2 molecule. So you will have the respiratory quotient equals to 0.7. So the respiratory quotient for the fats is 0.7. Similarly, if we consider the proteins as a respiratory substrate, 0.9 respiratory quotient. Alright. So if you take carbohydrates as a respiratory substrate for the respiration, you will get the respiratory quotient as a 1. While if you take the fats, you will get the respiratory quotient as a 0.7. Now, here is the exceptional case of the anaerobic respiration. Now, what happens in anaerobic respiration? CO2 is evolved during the respiration, but O2 does not taken during the reaction. So, for the anaerobic respiration, the respiratory quotient is always the infinity. Alright? We cannot calculate the respiratory quotient in the anaerobic respiration because oxygen is not taken in, but only the CO2 is evolved. So the respiratory quotient for the anaerobic respiration is always the infinity. Alright. Now let's take the reaction of anaerobic respiration in which we have C6 H12O6, which directly gives two molecules of C2H5OH plus two molecules of CO2 and energy. This reaction does not require any oxygen molecule. So during the calculation of respiratory quotient, we have here the two molecules of CO2 but zero oxygen molecule. So it will equals to the infinity. All right. So respiratory quotient during the anaerobic respiration is always the infinity, while if you take the carbohydrates as the respiratory substrate, then then the value of respiratory quotient is 1. For fats, it is 0.7. For proteins, it is 0.9. And for the anaerobic respiration, it is infinity. All right. So this is all about the respiratory quotient. So thank you very much for watching this video. Please like the video. Please share this video with your friends who are studying the botany, and please subscribe to the Botany optional channel for UPSC examination. Again, thank you very much for watching this video. See you in the next one.